I'm Dr. Thad Botham, and this is the third lecture in a sequence of lectures on logic. And today we're going to talk about the concept of validity, in particular, when an argument is valid or invalid. As a sense of motivation or a point of motivation, notice that when we speak with one another or write things to one another, oftentimes we're expressing a way to view the world. Sometimes we believe one another and all is fine. Sometimes we disagree with one another. Or sometimes we're skeptical about another person's claim and we'd like to see some further reasons. Why would anyone believe that? And in which case, maybe the request here is to offer further reasons for believing a certain claim about the world, about the way things are. Hopefully these further reasons are obviously true, at least to the people involved. And the hope is that these reasons really do support the claim in question, the claim that we disagree about, or the claim that we're initially skeptical about. And this lecture covers the gold standard, really, for the conditions under which the reasons really do count as reasons, really do count as support for a given claim. And this lecture outlines the gold standard, the highest of standards, for when a given set of claims or chain of reasoning provides absolute support for a given claim or conclusion that's under question. Okay, let's get to it. This chain of reasoning in support of a claim, the claim under question, is called an argument. An argument, by definition here for purposes of this course, is a set of at least two claims or propositions, where one is definitely the conclusion, and then the remaining claims are the premises. Maybe there's just one premise, one reason for the conclusion. Maybe there are several. Maybe the chain of reasoning is quite complicated. But we need at least two. No argument is true, and no argument is false. This would be a category mistake of sorts. It would be like saying green weighs 3 pounds. It's just not something that falls in the scope of being green to weigh 3 pounds. It would be a category mistake. Likewise, no argument is true. No argument is false. Rather, the claims within an argument, the claims constituting the argument, might be true or false, but the argument itself is not true or false. Rather, for any argument you take, it's either valid or invalid. You can assess for any argument proposed whether the relationship between those premises and that conclusion is a valid relationship or an invalid one. Another way to say that an argument is invalid is to say that it's fallacious, or that that inference between those premises and the conclusion does not follow. What is it for an argument to be invalid? What do you think? Can you give a short, concise characterization of what it means for an argument to be invalid? WTF. An invalid argument means there is a WTF. Now, this is my technical machinery. It's not standard in the literature, of course, but I think this is one of the easiest ways to capture and remember the conditions under which an argument is invalid. There is a WTF. What do we mean by WTF? W, there is a possible world where T, the premises are true. F, the conclusion is false. WTF. This is what I think the easiest way to capture and remember when an argument is invalid. It will never fail you. You can use this WTF method, we can call it, to discern whether or not a given inference captured in an argument is valid or invalid. If there is a WTF, and it has to have three elements. The first element, W, there has to be a consistent situation, a possible situation, where the premises are all true, while the conclusion is false. If there is such a possibility, where the premises are true and the conclusion is false, that means, that guarantees, that the argument is invalid. So what is it for an argument to be valid? Well, there's no WTF. Another way to say it is one has a valid argument precisely when it's impossible to have true premises with a false conclusion. Right? If there's no WTF, there is no W, there's no possible situation where you have true premises with a false conclusion. So this second bullet point here says exactly the same thing as the first bullet point. Here's another way to say the same thing. A valid argument means that there is no consistent way things might be, where the premises are true while the conclusion is false. Mastering the machinery in this slide, the conceptual machinery, will enable you to, with precision and speed, ascertain whether or not a given inference in front of you that you're thinking about is valid or invalid. The WTF method will not fail you. So let's try it out, and we'll go through some exercises, but really this is the lesson. Invalid argument means there is at least one WTF. So when you can see that and grasp that there's a WTF, that'll be your counterexample to the argument's inference. If you can grasp, on the other hand, that there is no WTF, you see that, well, wait a minute, when the premises are true and the conclusion is false, that guarantees an impossible situation that would contradict ourselves, making the premises true while the conclusion is false. And if it's contradictory to make the premises true and the conclusion false, that means there is no WTF and the inference is valid. So let's go through some examples and practice, test ourselves whether or not the inference is valid or invalid. Let's take this situation, this argument. It's an argument because we have at least two propositions, and in fact here we have three. Each of them are numbered. Each of them is numbered, I should say. One is the conclusion. We've put it there at the bottom, and we've added the word thus to indicate that we have a conclusion. And the other premises The other propositions count as the premises. So the question is, does this conclusion follow from the premises? Is the relationship here between premises and conclusion valid? Is this a valid argument? What do you say? It is. It's a valid inference, and this inference form is called conjunction introduction, right here, or ampersand introduction, because we introduce in our conclusion a conjunction. Here's the first conjunct, and then here's the second conjunct. We are slow. And we can see that there's no WTF because any possible situation whatsoever where the premises are true, we are Michigan students, that possible situation also includes we are slow, and what we mean here is maybe intellectual aptitude, not pace of our rate of speed that we move around. It guarantees that 3 is true as well. There's no possible situation where the premises are true and the conclusion is false. Pretty easy stuff here. So this is a valid argument form. Anytime for any propositions you pick P and Q, and they might even designate the same proposition. This inference form is guaranteed to be valid. And once you see that an inference follows a valid form, you can always trust that inference. There's never going to be a counterexample situation, a WTF to that inference. So always trust this inference. Here's a different inference form, conjunction elimination. So we have a premise that is itself a conjunction, and we eliminate, we remove at least one conjunct. Here we have a conjunction that has only 2 conjuncts. The first conjunct is we all love philosophy. The second conjunct is we all drink coffee. And we remove one of them. It doesn't matter really which one, but in this case we remove the second conjunct. We remove the first conjunct and wind up with the second one. Is this a valid inference? Or, alternatively, is there a WTF? No WTF here, right? In any possible situation, and you can see this, where the premise is true, that will thereby guarantee that that conclusion is true as well. A conjunction means every single conjunct is true. Always trust this inference, and it doesn't matter which one you pick here. Could be the second conjunct, could be, we could have just as well put P right here. But if you have a conjunction, each of these conjuncts validly follows. All right. Here we have disjunction introduction. We have a disjunction here as the conclusion. We are studying logic, or Bush is the greatest president there ever was or there ever will be. Is this a valid inference? Test yourself. What do you think? Remember that a disjunction P or Q, or a disjunction maybe with 3 disjuncts, P or Q or R, a disjunction is true precisely when at least one, maybe more, of its disjuncts are true. At least one. That's all logicians care about, and that's all we care about for purposes of this course. A disjunction is true when at least one of those disjuncts is true. And the disjuncts are separated by the operator or term or. So, is there a WTF to this inference? No, there's not. So this inference is valid. You may be wondering, so Thad, does this mean we can just add on with the term or anything we want? Any rubbish, any claim, whether or not it's true or false, we can just tack it on so long as we add it as a disjunct and we're guaranteed to have a valid inference? Yes. Yes, we are. And it turns out that this inference form is pretty powerful in certain arguments. But here's an example of a valid inference. Let's test it. Let's try to imagine a WTF situation, a world, possible world, where the premises are true and the conclusion is false. Here we only have one premise. So make this conclusion false. How do you make an entire disjunction false? Well, remember the entire disjunction is true precisely when at least one disjunct is true. So to make it false, we have to make each and every disjunct false. So it's not the case in this possible WTF situation. We're trying to construct a counterexample. We have to make this false. It's not the case we're studying logic. And we have to make the other one false too. It's not the case that Bush is the greatest president there ever was or ever will be. So make both of those false. In that possible situation, that imaginary situation, is the premise, can we make the premise true as well, consistently? No, we can't. We've made it, we're studying logic false in order to make the conclusion false. And in so doing, we made this premise false. So to make the premise true in that situation contradicts ourselves. And we can see that. We can see that there is no possible situation where the premise is true and the conclusion is false. So this inference is valid. You may always trust this inference form. For any propositions you pick, for P and Q, this inference form will always be valid. Consider this argument. Test yourself. Do you think the argument's valid or invalid? Notice the conclusion is false. Notice premise 2 is false. Nonetheless, the argument is valid. Validity, this example shows, has very little to do with whether or not the premises or the conclusion really are or is true. Rather, validity is a relationship between the premises and the conclusion. And the relationship is this: when the argument is valid, there is no WTF. There is no consistent way things might be where the premises are true while the conclusion is false. That's what validity means. If there is a consistent way things might be where the premises are true while the conclusion is false, the argument is invalid. This argument is valid. In fact, it has the form modus ponens, and that form is always valid. Let's test it. Imagine a situation where there is a WTF. Let's try. I like to start by making the conclusion false. So make that conclusion false. The sky is poisonous, make that false. So the sky is not poisonous. It's not the case that the sky is poisonous. Now, is that so far a consistent situation? Sure. Okay, we're halfway there. The sky is not poisonous in our imaginary situation. Now, can we consistently add the premises in our imaginary situation where the sky is not poisonous? Add the sky is green. Is that consistent? The sky is green and not poisonous. Sure, so far We've made the conclusion false. We've added the second premise. Can we consistently add the first premise? If the sky is green, then the sky is poisonous. So that's true precisely when there's no bad boy. There's no situation where the antecedent is true and the consequent is false. So the sky is green in our imaginary situation. And if the sky is green, then the sky is poisonous. It's not the case. This is true while this is false. Oh no, we've contradicted ourselves because we've made the sky is poisonous false. So we've landed ourselves in an incoherent situation when we've tried to make the conclusion false and the premise is true. And we can see now that there's no WTF. Here's another example of modus ponens. Test yourself. Is the argument valid or invalid? Notice premise 1, at least in our country, the United States of America, is false. Premise 1, in fact, is false. I have no idea whether premise 2 is true for you when that personal pronoun refers to you. When I assess this argument and that personal pronoun refers to me, 2 is in fact true. But these questions are a little bit beside the point, right? Whether or not the premises really are true. The question at stake now is whether or not the inference is valid. And remember, whether or not an argument is valid has very little to do with whether or not the premises are true or false. Let's try to construct a WTF situation. I'd like to start by making the conclusion false. Here's the conclusion. Make this conclusion false in an imaginary situation. Suppose you may legally drink beer. It's perfectly permissible. Add that you are over 25 years old. Are those two consistent so far? You may legally drink and you are over 25? Sure, that's consistent. Now add consistently, try to anyway, if you are over 25 years old, then you may not legally drink beer. Cannot do it. When we add that last element, that last claim to our possible situation, it lands us in an impossible situation. There's no consistent way the premises are true while the conclusion is false. So here's another example of a valid argument. And since it follows this form, modus ponens, the inference is guaranteed to be valid. What do I mean by follows the form? Anytime you have a claim that's a conditional claim, and the antecedent is the exact same proposition, then you may validly deduce the consequent of that conditional. But these have to be the exact same propositions. So if you, for example, are extracting someone else's argument, you're distilling it into a rigorous premise, conclusion format, and you cite the rule modus ponens. You cite that rule at the conclusion line here, then it better be the case that your conclusion is the exact same proposition as the consequent of that conditional. One way to do it is make sure the words are exactly the same. You can copy and paste the one for the other. Likewise, the antecedent needs to be the exact same claim as the antecedent. If they say different things, then you're really not using modus ponens. So be careful to make sure those claims are exactly the same when you use modus ponens. Here's a little bit of a different argument structure, a little less intuitive than modus ponens. A lot of students have no problem whatsoever understanding that. Let's go back. A lot of people have no problem seeing that this argument form is valid. That's modus ponens, and we're going to move now to modus tollens. Is modus tollens a valid argument form? Here's an example of modus tollens. I'll let you read it, and why don't you go ahead and take a stand for yourself whether or not you think the argument is valid. If you're unsure, or whether or not you're sure, let's just try to use the WTF method. Let's try to come up with a world where the premises are true and the conclusion is false. And the world has to be a possible world, a consistent situation. I like to start by making the conclusion false. One way to make that conclusion false is to make it such that you are a human being. So imagine a consistent situation where you are a human being. And now add premise 1. You are a human being, and we add this conditional. If you are a human being, then you are exactly 2 feet tall. If you noticed that when we add premise 1 in this possible situation where you are a human being, by modus ponens, remember that last valid inference, it guarantees in that world that you are exactly 2 feet tall, right? 1, together with you are a human being. Remember, we said that because we're making this conclusion false. By modus ponens, you are exactly 2 feet tall in that imaginary world. In which case, when we go to add that last premise here, we contradict ourselves. You are exactly 2 feet tall, and yet we add premise 2. You are not exactly 2 feet tall. We've contradicted ourselves. And we can see that we contradict ourselves, right? So no WTF. We worked our hardest to construct a WTF, and in so doing, we landed ourselves into an incoherent and inconsistent situation, in which case it's not possible anymore. It's impossible. No WTF. So the inference is valid. Here's another case of modus tollens. I'll let you read it. Notice the conclusion is false. Premise 2 is false. And yet the inference is valid. Let's convince ourselves that the inference is valid by applying the WTF method. Think of a consistent situation in which the conclusion is false. One way to do that is to imagine a consistent situation where Abe Lincoln died. Okay, is that consistent? So far, so good. Now add premise 1. Remember, in our situation, Abe Lincoln died. Now add, if Abe Lincoln died, then he was shot. Aha! By modus ponens, that means he was shot. And then we go and add this last claim. He was shot and he was not shot. That's not going to be true. That's a contradiction. So we have Guaranteed, we're in an inconsistent situation, so no WTF. Anytime we have 1 and 2 true, that will guarantee that 3 is true as well. There's no possible way for 1 and 2 to hold while 3 is false. So here's an inference form that you can always trust. If you can see that an argument under your consideration has this form, you can trust it. You can trust the inference. I'm not saying believe the conclusion, because it's a different question whether or not the premises really are true. But you can trust the inference. Now, what's going on here? I've inserted this little parenthetical. It's saying the same thing as this. It's not the case that Q, this little negation symbol means not. So this is just a bonus feature of the form. When you see this, you can read it as it's not the case that Q, or Q is false. It says the same thing. So any inference of this form where you have a conditional and then another premise denies that consequent, you may validly deduce the denial of the antecedent. Okay. Here's another example. This first premise is a disjunction with only 2 disjuncts. The second premise denies one of the disjuncts, and the argument concludes that the remaining disjunct is true. Valid or invalid? What do you say? It's valid. Let's test it. I like to start by making the conclusion false. Sam is in New York. Well, let's make that not the case in an imaginary situation. So make sure Sam is not in New York. Now make the premises true. Let's go to premise 1. Sam is in Colorado or Sam is in New York. So in our imaginary situation, 1 is true as well. And we already are sure that Sam is not in New York. He's nowhere near it. And 1 says, well, at least one of these is true. Either Sam is in New York or, either Sam is in Colorado or Sam is in New York and he's not in New York. Can we consistently add this last premise? And Sam is not in Colorado. He's in at least one, Colorado or New York. He's not in New York. We made sure that was mistaken. And he's not in Colorado. This will be an inconsistent situation. Another way to say it is any possible world you pick where 1 and 2 are true. That will thereby guarantee that 3 is true as well. Here's another example of the same inference form denying the disjunct. We have one disjunct and another premise denies it. And we conclude the other disjunct, or the remaining part of that disjunction, is true. Valid. Always trust it. An argument in this form, regardless of what propositions you pick, will result in a valid inference. It doesn't matter which disjunct you deny. You don't have to deny the first one. This could have just as easily said Q, in which case this one would have needed to say P. But if you deny one of them, then you may validly conclude the rest. Okay? Let's consider this next argument. I'll let you read it. This argument is of the form affirming the consequent. Remember, the consequent, or a consequent, is the then clause, the necessary condition of a conditional. And this is an argument, one of whose premises is a conditional, and the other one affirms the consequent, says it's true, and concludes, rightly or wrongly so, that Sid Shady goes to the party. Question, is this a valid inference? What do you say? Well, let's just attempt to construct a WTF scenario. I like to start by making the conclusion false. I think that's the easiest way to wrap one's mind around whether or not we can secure a counterexample situation for this inference. Sid Shady goes to the party. Let's make that false. Let's make sure Sid Shady goes nowhere near any party whatsoever. He is not a party-going person. He's maybe hermetic. He lives alone. He's no party animal whatsoever. Okay, we've got that possible situation. Maybe he lives in a cave somewhere. Can we make premise 1 true consistently? Sid Shady never goes to any party. But if Sid Shady goes to the party, then Victor goes to the party. Sure, that's consistent. Even though Sid Shady never goes to any party, if he goes to the party, not saying he does, then Victor goes to the party. In testing or in constructing your counterexample worlds, you can insert even if up here without a loss of meaning, and you can even put the word still into the consequent. For example, remember we're in a counterexample world, or a potential counterexample world, where Sid Shady never goes to any party whatsoever. He's in a cave. Even if Sid Shady goes to the party, then Victor still goes to the party. That is exactly what 1 says. Or when we add the even if and still, we do not change the meaning of it. That's just a little tip. And Victor goes to the party. Are all of those claims consistent? Sid Shady never goes to the party. We made the conclusion false. Even if Sid Shady goes, then Victor still goes, and Victor goes. Sure, that's a totally legit counterexample world. We attempted to locate at least one WTF, and we did. We secured it, and that's our counterexample situation, demonstrating that this inference is invalid. There is a consistent situation where all the premises are true while the conclusion is false. Invalid. So what's the lesson we learn from this? The lesson is, do not trust this argument form. Question, does that mean this invalid argument form will always have invalid instances when we plug in real premises into this form? Could we sometimes wind up with a valid inference? The answer is yes. So even though the argument form is invalid, it may turn out that there are valid instances of the form. There are particular examples where the inference is in fact valid even though we can't trust it. Now that last one, let's return to it. I'm going to rewind here, was clearly an invalid argument, and this instance is invalid. We secured a counterexample situation, the WTF, but we can also encounter arguments of this form that have valid instances. This is a pretty sophisticated point. Here's an example of an argument of this affirming the consequent form, but this particular instance is valid. See if you can convince yourself why. First, notice that the argument is of the form affirming the consequent. You have at least one premise that's a conditional. Here it is, premise 1. And you find that consequent and affirm it. You say it's true and conclude the antecedent is true. Now that's an invalid form, so don't trust it. But you should attempt to construct a WTF. The most charitable evaluation of this argument is such that you attempt to construct a counterexample situation. So suppose we try it. Suppose we make the conclusion false. It's not the case that there is a way things might be. Whoa. Right? There's no possible situation where it's not the case there is a way things might be. Because whatever possible situation there is, that would be a way things might be. So already when we deny 3 in order to come up with the WTF, false conclusion for F, when we reject 3, we are already in an inconsistent situation. Why? Because 3 is necessarily true. No way to make it false. No possible way to make it false. Here's another argument form. And we should ask ourselves, is this argument form always valid? And we can also ask ourselves if this instance of the form is in fact valid. I'm sure either you've encountered an argument like this in your past, or you've heard of people encountering an argument like this, or you've perhaps even delivered an argument like this. I've heard an argument very similar to this from my caregivers. And what is the proper response from a logical point of view to an argument like this? Suppose you're the young child, and you're sitting in your seat and you don't want to eat your peas. And they're just sitting there growing cold. And your caregiver issues the following argument, advances it to convince you you just need to eat your peas. What's the proper response? I submit the proper response is WTF. Why? There is a WTF situation. Start by making the conclusion false. The conclusion actually says you will not get dessert. One way to make that false in an imaginary, consistent situation would be you get dessert. Is that consistent? Sure, you get dessert. Maybe it's cheesecake. Maybe it's Boston cream pie. Let's stick with cheesecake for now. New York creamy cheesecake, maybe with some strawberries draped over the top. And in a possible situation, you get dessert. Now, make premise 1 true. If you eat your peas, then you get dessert. Is that consistent with you do get dessert? There you are, eating it. Could it also be true that if you eat your peas, then you get dessert? Sure. No consistent situation there. No inconsistent situation there, I should say. It's completely consistent. Now add, you did not eat your peas. Is that consistent? Those three claims? You eat dessert, and here's the tip, even if you eat your peas, then you will still get dessert. And you did not eat your peas. Suppose you're going to get dessert no matter what in this imaginary possible world. Suppose you get dessert whether you like it or not, whether you eat your peas, even if you don't eat your peas, you get dessert. We're going to cram it down your throat. Okay, that's a little hyperbolic, but you get the point. There is a consistent situation where the premises are true and the conclusion is false. So this is an invalid inference. WTF. Now, which argument in the neighborhood is the more persuasive, more accurate, more, well, valid inference? It seems that your caregiver, my caregiver, for example, should say, you get dessert only if you eat your peas. In other words, we're looking for the conditional version of one where it's if you get dessert, then you eat your peas. You don't eat your peas, therefore you do not get your dessert, a la modus tollens. But notice that's not the example shown on the screen here. Rather, we have an invalid argument form and an invalid instance. So here's another example. Imagine a consistent situation where pigs fly. There they are. They've got itty bitty tiny wings like a bumblebee compared to their body, but they're flying around. And we make premise one true if, or even if, explosions in the sky is a lame band, then pigs still fly. They fly, and even if explosions in the sky is a lame band, then pigs fly. And turns out explosions in the sky is not a lame band. That's a completely consistent situation. Could be that pigs fly regardless of the status, the lameness status of explosions in the sky. So, in any possible, so there's at least one consistent situation, a possible world, where 1 and 2 are true, and yet 3 is false, illustrating the fact that this argument is invalid. So here's an invalid argument form, but there may be valid instances of the form. So what's the lesson we can take away from this right now? The lesson is anytime you have a valid argument, a good one, a valid one, trust it. Anytime you have a valid form, trust it. You don't even need to look at what the premises really do say. You can just see that the argument is in the valid form and trust it. However, when you encounter an argument in an invalid argument form, suspicions should wax thick. Be skeptical and then test it. Test whether or not the argument, the particular instance, is valid. For example, here's a valid instance of the invalid argument form denying the antecedent. Notice the premise 2 denies the antecedent. Here's the antecedent of a conditional. And then the conclusion denies the consequent. So it fits the form, denying the antecedent, but notice this argument form, while invalid, the instance, given what the premises really are saying, is valid. Why? Look at the conclusion. To come up with a counterexample situation to this inference, we need to have a case where the conclusion is false. What would that be? It's false that it's not the case that 2 plus 3 is 7. Well, to say 3 is false, we can just remove this not. And imagine a consistent situation where 2 plus 3 equals 7. Is that even possible? No. That's impossible. You might think, well, Thad, what if the words 2, what if that symbol 2 and that symbol 3 referred to different things? And, well, this is interesting. We're talking English, and we're presenting these slides in English, and the proposition that these characters, this string of characters, picks out is a proposition that's itself true in no possible situation. So there's no WTF. Why? Because there's no possible situation where the conclusion is false. Now, that came probably pretty quickly. If so, feel free to review. Suppose we encounter an argument like this. No need to suppose, really. Here we are. So we have a disjunction, premise 1, and we affirm one of them. We say it's true. Affirm is to say it holds. So the Irish will lose or Sam Slug gets drunk. And, premise 2, the Irish will lose. Therefore, Sam Slug will not get drunk. Valid inference or not? Remember, a disjunction is true precisely when at least one, maybe more, of its disjuncts are true. So, consider a WTF as follows. I like to start by making the conclusion false. It's false that Sam Slug will not get drunk. One way to do that is to just say, well, Sam Slug gets drunk. Okay, in our imaginary situation, Sam Slug is drunk. May we consistently add 1? The Irish will lose or Sam Slug gets drunk. At least one of those is true. Sure, that's consistent. So we have a counterexample situation so far where our conclusion is false. So far, so good. 1 is also true. So far, so good. May we consistently add premise 2? The Irish will lose? Sure, no problem. And in that situation, both disjuncts of 1 would be true. So affirming the disjunct is an invalid inference form. Don't trust it. But again, that does not guarantee that every instance of that form is likewise an invalid instance. Here's an example of a valid instance of the invalid argument form. I'm not going to read through this or explain why. I'll let you convince yourself with the information available. Okay, as a bit of review, we have 2 more slides, and you may find this helpful. Question: are there any valid arguments with false premises and a false conclusion? Is that even possible? Yes. Consider this example. Premise: the moon is made out of cheese, Swiss cheese. Therefore, the moon is made out of cheese. Here you have a valid argument, P, therefore P. And it's not the case that the premise is true, not the case that the conclusion is true. False premise, false conclusion, yet it's a valid inference. Are there any valid arguments with false premises and a true conclusion? Sure, no problem. There are some cases of that. Consider this argument. Premise: the moon is made out of cheese. Conclusion: therefore, either the moon is made out of cheese or dolphins swim in the ocean. That conclusion is true precisely because at least one of those disjuncts is true. Namely, dolphins swim in the ocean. Are there any valid arguments with true premises and true conclusion? I sure hope so. This would be a great thing. Unfortunately, it is a great thing that there are valid arguments with true premises and a true conclusion. In fact, this is what we're looking for a gold standard argument. We want a valid argument with true premises because that guarantees that conclusion is true as well. So you have two people, one's persuading the other to adopt a view that the other is skeptical about. She advances true premises, uses a valid inference to derive a conclusion. Guess what? We can be sure that conclusion is true as well. Are there any valid arguments with true premises and a false conclusion? Absolutely not. This is the only case of these four combinations where you will not have a valid argument. This is precisely a case where you're guaranteed not to have a valid argument. It's impossible to have a valid argument with true premises and a false conclusion. What about the combinations of an invalid argument? Might you have an invalid argument with false premises, an invalid argument with false premises and a false conclusion? Sure. How about the moon is made out of cheese, therefore there are no jellyfish? That would be invalid. Why? Because you could make that conclusion false while making the premise true. Even though the premise is in fact false, there is a consistent situation, a wild and crazy, maybe possible situation, where the moon is made out of cheese, and yet that conclusion is false. Is there an invalid argument with false premises and a true conclusion? Sure. The moon is made out of cheese, therefore we're sitting at a computer. Or the moon is made out of cheese, therefore dolphins swim in the ocean. That would be an invalid argument. Why? Because it's possible that the moon is made out of cheese, and yet it's not the case that dolphins swim in the ocean. Maybe they only exist in a swimming pool or a big marine aquarium and never are in an ocean whatsoever. That's possible. Are there invalid arguments with true premises, true conclusion? Sure. I'll let you come up with your own. True premises and a false conclusion, could you have an invalid argument there? Absolutely. In fact, any argument with true premises and a false conclusion is guaranteed to be invalid. Okay, that's it for this lecture on validity. This is Dr. Thad Botham. Until next time.